ants use math to create bridges. Researchers at the Institute of Technology in New Jersey have studied the algorithms that nomadic ants use when building bridges. When the first of the chain of ants runs into an empty space, he freezes so that the next participant in the chain can climb on it and continue on his way. Thus, living dynamic structures arise, with the help of which the colony overcomes difficult areas in the shortest way. When scientists proposed to the ants, http://www.dailymail.co.uk/science-article-549960055/army-articles-living-bridges-bodies.html, V-shaped obstacle, they, calculating the smallest the effort also developed into a V-shaped figure. It is noteworthy that ants can estimate the number of comrades involved in the construction of the bridge and decide whether there is a need to expand it. During the movement of the colony, up to 20% of its participants can be simultaneously involved in the construction of such a bridge. When an ant meets a pit or ditch in its path, it slows down. The remaining individuals, still moving at a speed of 12 cm/s, begin to move along its back. At this point, two rules begin to apply. The first says that when an ant feels that others are walking along it, it must freeze in place. This happens with the following ants: another one climbs on the first ant, and if the pit in front still hinders the passage, the next one climbs on his back, it freezes, and so on. Thus, they can build a bridge of any length, and the remaining colony ants pass along it. However, this is not all. When constructing such bridges, ants also make compromises. Imagine, for example, that a letter V failure occurred on their way. The colony would not have gone around it as it would take too much time, but it would also not build a bridge across the widest section of the whole that would allow them to reduce the distance traveled. The fact that ants do not always build distance-reducing bridges means that other factors are included in the decision-making process. Such a failure puts them in front of the need to find a compromise solution, because a more direct path will require the construction of a bridge of more individuals. The data obtained are important not only for studying the group behavior of animals, but also for modern robotics. Researchers working to create swarms of simple robots are still thinking of an algorithm that would allow their machines to perform actions similar to building ants by bridges. This example is important for several reasons. Ants do not have a centralized organization, their algorithms are well designed and reliable, as well as less resource intensive than those that scientists managed to create for the swarm of robots to function.